Hi, it's Ms. Richmond. We're talking about graphing equations with two variables. But before we do that, let's remind ourselves, what is the term solution of an equation? What does it mean to be the solution? Well, we know a value is a solution of an equation if it makes the equation an identity. That means it makes the equation true. For example, 3 is a solution to 4x plus 2 equals 14 because if we substitute 3 in for the x, we get the true statement 4 times 3 plus 2 equals 14, and this is 12 plus 2. So yes, it does equal 14. It's an identity. So 3 is in fact a solution to this equation. The same is true for an equation with two variables. For example, the ordered pair 2, 3 is a solution to the equation x plus y equals 5 because when I substitute x equals 2 and y equals 3 into my equation, I get a true statement. I get 2 plus 3 equals 5. So it makes the equation an identity, and so 2, 3 is a solution. So to test if an ordered pair is a solution, all we have to do is substitute the values in for x and y. Here's an example. Is 4, negative 5 a solution to 3x plus 6y equals 18? Okay, so we just try it out. We put in 4, negative 5 in for x and y. So when we substitute that in, we'd have 3 times 4 plus 6 times negative 5. That would give us 12 plus negative 30, which is negative 18. But our equation said positive 18, which means that 4, negative 5 is not a solution. So when we graph an equation in two variables, what we're really doing is showing all the points on a graph that are the solution. So our graph are all the solutions of the equation. One way to graph an equation is to make a table of values and then graph the values and look for a pattern. When we make our table and we pick values, we have to be sure we use both positives and negatives in our table. Here's an example. To graph negative 2x plus y equals negative 4, that means we're looking for all the values of x and y that would give us a true statement. So we can make a table or a chart, and we can put in some values for x and some values for y, and we'll pick some nice x values to use. Maybe we'll use 0, 1, and negative 1. And then we need to find our corresponding y values. So when x is 0, I'll put 0 in to my equation, and I would have negative 2 times 0 plus y equals negative 4, which would mean that I would have 0 plus y is negative 4, so y would be negative 4. So I'd put negative 4 here. When x is 1, I do the same thing. I take the 1 and I substitute it in for x in my equation. So I would have negative 2 times 1 plus y equals negative 4, which would mean negative 2 plus y equals negative 4. And to solve this, I'd add 2 to both sides. And so I would get y equals negative 2. And lastly, when x is negative 1, again substituting into the equation, I'd have negative 2 times negative 1 plus y equals -4, which would mean +2 plus y is -4. So if I subtract 2 from both sides, I get y is -6. Notice each and every time I had to go ahead and solve for y. That gets repetitive and takes a long time. So there is another option, which is we could solve for y first before we start putting in values for x. So we can use the literal equations and we can solve this for y. So remember, I need to move the -2x. So I would add 2x to both sides. And that would give me y equals 2x minus 4. Notice, as it says here, that unless it's stated otherwise, we can assume that the domain is all real numbers. So that means I can put in any values I want for x. So if I put in the same values, 0, 1, and -1, notice that it will be much easier now to solve because I know that y is 2x minus 4. So when x is 0, and I put in 0 here, I'll have 2 times 0 minus 4, which is 0 minus 4, or -4. When x is 1, I have 2 times 1 minus 4, which is 2 minus 4, or -2. And when x is -1, I have 2 times -1 minus 4, which is -2 minus 4, or -6. So that went a lot faster once I solved for y. So now I can go ahead and plot these points. When x is 0, y is -4. I'm going to assume on the graph that these are all going by ones. So this would be 1, 2, -1, -2, 1, 2, etc. So when x is 0, y is -4. 1, 2, 3, 4. When x is 1, y is -2. And when x is -1, y is -6. 1, 2, 3, 4, 5, 6. Notice, since my domain is all real numbers, all of these in between numbers work as well, and it would continue on forever. So hopefully you can see that this is a nice line, and so I can go ahead and complete that line. It's going to go here through my other points and would keep going on forever. And it would also keep going on forever in the opposite direction. So my line would look like that. So we've seen that by graphing the equation, it helps to solve for y first. Pick some values of x to plug into or substitute in your chart. Put those in your equation for x, and then find the values of y and graph your points.